Hello judges, we are Team Jaihind from IIT Patna and this is the technical proof of concept for our solution. FinTrace, an AI-powered banking fraud detection platform, we are tackling problem statement 3 for Union Bank of India, tracking of funds within bank for fraud detection. Traditional tabular databases struggle to catch complex multi-layered money laundering. Today, we will demonstrate our working prototype which uses a Stack frontend, a Neo4j graph database backend, and Python-based machine learning model to track the flag malicious fund flows in real time. For this demo, we are using a robust synthetic dataset simulating millions of banking logs. Welcome to the FinTrace admin dashboard. Immediately, investors get a real-time pulse of the network. Our synthetic pipeline has processed over 12,400 transactions successfully, detecting 47 fraudulent anomalies with a 99.6% success rate. But rather than just showing historical data, we want to prove our ML engine works live. This is a live ML risk analyzer. It interfaces directly with a Python fast API backend holding our anomaly detection model. Let's run live assessment. I am going to input synthetic dataset for account ID ACC001. As you can see, model successfully evaluated the features. It returned a low risk status with 34% fraud probability and generated an automated natural language explanation of the anomaly score. This proves our end-to-end AI pipeline is fully functional. We also get the performance matrix and recent security alerts in the dashboard itself. Let's move to alert section. When our ML model flags an anomaly outside of a defined threshold, it routes directly to the fraud alerts queue. Here, investors see exactly why a transaction was stopped. For example, account ACC 2024-001 triggered a high risk alert for a rapid transaction detected with a 78% fraud score. Below that, we caught a medium risk alert for unusual location. We aren't just giving investigators raw data, we are giving them categorized actionable intelligence. If an investigator needs to see the raw ledger, our transaction history page pulls directly from our database. It shows the real-time status of an online transaction, ATM withdrawals and declined payments. Notice of how TXN001 from the flagged account is logged here seamlessly. The core difference is a graph visualization. While tabular logs are great, the true innovation of FinTrace is our Neo4j Graph Investigator. Let's look at the transaction network visualization. Traditional databases would require complex, slow SQL joins to track money moving from account A to account B to account C. By modeling accounts as nodes and transactions as edges, our system plots the exact trajectory of funds instantly. Here you can visualize, see the risk distribution. Nodes 002, 004 and 006 are flagged in red as critical. If this were a smurfing or round tripping attack, the investigators would see the visual loop forming right here on the screen, cutting investigation time from hours to seconds. To support bank management, our report and analytics dashboard aggregates this graph and ML model into a 7-day transaction trend. It clears breaks down the account risk distribution, showing exactly how many accounts sit in the critical high and medium threshold. Finally, detecting fraud is only half the battle, reporting it to the other. Union Bank must comply with the RBI regulation. Our FIU export center bridges this gap. With a single click, investigators can export the visual graph, transaction chains, and an ML anomaly explanation into a standardized PDF evidence package or a CSV ready for immediate submission to the financial intelligence unit. They can also change the settings of the dashboard. In summary, FinTrace is a fully functional end-to-end prototype. We ingest data, map it via graph database, analyze it with machine learning, and visualize it for the investigator. We have successfully proven that we can replace manual log tracing with intelligent automated network analysis. Thank you for your time, and we look forward to the next phase.